Okay, students, today we're going to work on factoring. We're going to do a few different types of factoring. Okay, so we're going to start out with difference of squares. And then I'm going to do some examples, and then we're going to do a warp sheet. So you have examples of the warp sheet of the types of problems on there. So when you do warps, you have examples to write down as well. You need to look back at them. All right, so difference of squares. Difference of squares, and it used to be called difference of perfect squares. They just dropped off the name perfect and just left it as difference of squares. When I grew up, it was called difference of perfect squares. Is difference means subtraction, and squares, each term is a perfect square. PS for perfect square, and there's only two terms. It's a binomial, or two terms. It's called a binomial. Okay, so example, 9x squared minus 25y to the fourth. When I see a binomial, the first thing, or any polynomial, the first thing I'm looking to do with factoring is to factor out the GCF. Is there a GCF? We already know that we talked about factoring before. Is there a GCF here? No. Next thing I ask myself, is it a binomial or a trinomial? If it's a binomial, I'm immediately looking for difference of squares. Okay? Is there a difference? Is there a minus sign? Yes. Is that a perfect square? And is that term a perfect square? 9 is a perfect square. X squared is a perfect square. 25 is a perfect square. Y to the fourth is a perfect square. The square root of y to the fourth would be y squared. You take half of the exponent. So it must be an even exponent. If it's an even, then it's a perfect square. If it's odd, it can't be. It's not. Okay, so it must be even. So I just take the square root of each. That's 3x. I put 3x and 3x. And I take the square root of 25y to the fourth. That's 5y squared and 5y squared. And one's a plus and one's a minus. It doesn't matter which one I put the plus on and which one I put the minus on. That's the simple rule on how to factor a difference of squares. Now, if I want to guarantee I'm right, I could distribute it back through. 3x times 3x, there's my 9x squared. There's a positive 15xy squared. There's a minus 15xy squared. That's 0. That's why there's no middle term. It's always a binomial. Wipes out the middle term. And lastly, I have negative 5y squared plus times positive 5y squared is negative 25y to the fourth, which is what I have right there. So you can always multiply them back out if you want to guarantee you have it right. If you can't, if you're not confident in doing the perfect square of each and put one as a plus and one as a minus. Let's do one more example. Let's say I have 16x to the fourth plus 64x squared. Oh, sorry, not plus. Can't be plus. Got to be minus, right? Difference of perfect squares. It's always got to be minus. Okay. So you might go ahead and say, okay, yeah, each of those is a perfect square, but you would have forgotten step one of factoring. What is step one of factoring? Factor out the GCF. The GCF of 16x to the fourth and 64x squared is 16x squared. 16 goes right into 64, and there's two x's in each of those. So I have to factor out the GCF, the most amount of x's I can. So that means I divide each term by 16x squared to see what I have left, which now just gives me x squared minus 4. Okay, so I factored out the GCF. That was step one. Factor out GCF. Remember, there was no step one on the other one. There was no GCF to take out. Step two, factor what's left if possible. That means inside parentheses. It's not always possible. So I look at what I have left inside the parentheses. I have a binomial. If I have a binomial, immediately what I'm looking for is difference of squares. First off, before I even do that, I need to ask myself, is there any more I can take out of there? Because maybe I didn't take out the full GCF. Is there an X in common? No. Is there a number in common? No. So I did take out the full GCF, but I need to check that first to make sure I did take out the full GCF. I see a binomial left. First thing I'm asking myself is a difference of squares. And yes, it is. X squared is perfect square and 4 is a perfect square. So now my final answer is 16x squared. I take the square root of each, x and x, 2 and 2, and put 1 as a plus and 1 as a minus. And there's my answer. Okay, so there's your two types of difference of squares, one where you don't have a GCF to take out and one where you do have a GCF to take out. Okay. Oh, I thought I had another. Oh, I put it on 2. Okay, so I'm going back to 1. Okay. So that's difference of squares. The next thing I'm going to look at is just factoring out a GCF. I could have done this first. Okay. Usually you're not just factoring out a GCF in a problem. You know, that rarely occurs sometimes in Algebra 1, but just to review the very basics. Let's say I have 2x plus 8. I take out the GCF of 2. I'm left with x plus 4. Or let's say I have 8x to the 4th plus 12x to the 6th. I see 4 is the GCF there, and I can take out a total of 4 x's from each one. So I'm left with 2 plus 3x squared. Again, I could check that I'm right by distributing it back through, and I better get what I started with. And again, to make sure that I didn't, or that I did take out the full GCF, I look here. Is there anything more I can take out of each of those terms? No, there's not. So I did take out the full GCF. Okay, and doesn't have to be plus signs. It could have been minus signs. It could have been more. Could have 4x squared plus 6x to the 5th minus 10x. It doesn't matter how many terms. That's a trinomial because there's 3 terms. Doesn't matter how many terms. I'm still looking to factor out the GCF. What's the GCF of the numbers? 2. How many x's can I take out of each? The most I can ever take out is the least number of them. 1. I can only take out 1x. Okay, so I take, do we do 4x squared divided by 2x? I get 2x. 6x to the 5th divided by 2x. I get 3x to the 4th. Negative 10x divided by 2x, I get negative 5. And there's the answer. Okay, again, I check inside the parentheses. Is there anything more I can take out of each term that I might have forgotten? No, there's not. So I'm done. And again, I can guarantee I'm right then by distributing it back through there. And I would get that right that I started with. Okay. So notice number 1 here, that's the difference of squares. Okay. Now we're going to go to the Carlson method of factoring before we go back to those examples there. Okay. I've already sent you a video out on this again, but several of you are struggle with factoring. Many in Algebra 1 did. So I'm putting it all together again right here. So you watch it again and get it pounded in your head. Again, my method's the quickest method, fastest method. You can get it done in one line as opposed to multiple lines or having to do boxes and other methods. Okay, so again, let me bring up some more examples before we go back to those examples. Okay, let's do these last 2. Maybe we'll do number 2 as well. We'll start with these 2, and then if we need to do more, we can go back to we'll go back and do the other examples. All right. So the first thing in factoring is determine whether it's solving the quadratic or just factoring. If there's an equal sign, that means we're solving it. Okay, and we need to, first thing we do with all quadratics is set equal to 0. Well, in this case, it's already set equal to 0. Notice on number 5 here, there is no equal sign, so we're not having to solve. We're just factoring, and we're done after we're factoring. The difference between solving and solving, after I factor it, I need to set each factor equal to 0 and come up with the actual answers. I'm done after I factor it when there's no equal sign. Okay, remember, that's called an algebraic expression versus an equation. An algebraic equation when it has the equal sign. All right, so first thing I want to do, factor out the GCF or divide. If it's an equation, I can just divide by the GCF as long as it's only numbers. Okay, if I had a variable in it, I would need to actually take that variable out. But since this GCF is only numbers, I can divide by it, which would be -2. Okay, I always want my leading coefficient right here to be a positive, so I'm going to always take and divide by the negative. So now what am I left with? 4x squared minus 5x plus 1 equals 0. Okay, so by doing that, that's also making it smaller numbers to have to work with, which makes it much easier. Okay, so we know it always multiplies to AC every time and adds to B. Doesn't matter what method you do, you have to do this step right away. So we know this is A, because this is AX squared plus BX plus C equals 0. So 4 times 1 is 4, and it multiplies, adds to the middle term, the linear term. Remember, this is called the quadratic term, linear term, and constant term. Remember, constant is the number by itself without the variable. So what two numbers multiply to 4 and add to -5? That would be -4 and -1. Multiplies to +4 and adds to -5. Okay, so this is the key, is to come up with those two right there. Now, as I've shown you before, and you've watched in the videos before, this first term times this first term always has to multiply to that first term right there. Well, is there only one option that multiplies to 4x squared? No, I could have 1 times 4, or I could have 2 times 2. We know it's going to be x and x, that's what multiplies x squared. Now the question is, which is it? 1 and 4 or 2 and 2? Okay, well, what I do is I always start with the highest one. It's usually the easiest one to eliminate, or it works. Does 4 times a number give me -4 or -1? Yes, it does. And does 1 times a number give me the other one? Yes, it does. So therefore, it's going to be 4x and 1x. Then I go ahead and connect the two outer ones together and the two inner ones together. And these must multiply to these two numbers right here. So 4 times what gives me the -4? -1. 1 times what gives me the other one? -1. -1 does. And therefore, I am done right there in one line. I could guarantee I'm right by distributing it back through. I get 4x times x is the 4x squared. -4x plus a -1x is my -5x right there. And -1 times -1 is my +1 right there. You can always guarantee you're right by multiplying it back through. Those that can know your integers well can quickly multiply that in your head and add in your head, and you're boom, you're done. So if this was number 5, I would be done because there'd be no equal sign. But since it's got the equal sign, I got to set each factor. Remember, this is called a factor, and this one's called a factor. You set each factor equal to 0 and solve. Add the 1 across and divide by 4. And the other one, all I do is add the 1 across, and I'm done. So it's 1/4 or 1. Those are my two answers. Remember, quadratic, degree 2, tells me how many answers there are. There's 2 answers. So I better get 2 answers down here, which I do. Now, they could be 2 different answers, as these are, but they could also be 2 of the same answers. If it's a perfect square, it might come to x minus 1 times x minus 1, and the answer is just 1, but it happens to be twice. So even though you're only writing down the answer of 1 once, there's really 2 number 1s there, if it happened to be a perfect square, but there's always 2 answers. All right, so now let's go ahead and do number 5 here. Remember, our first step is factor out the GCF. We can't divide here. We do not divide by any GCF because there's no equal sign at all. So we're always having to factor out. So the GCF here would be 4x. I divide each term here by 4x. I get 9x squared plus 3x minus 2. Okay, I again check to make sure that there's nothing more I can still take out, that I did take out the full GCF. And there is no like terms, any common terms at all, I mean, in any of those, so I did take it out. Now I factor what's left if possible. Now, I've talked about this before, and I didn't do it on this last one, but we'll do it here. To check to see if that will factor, remember I can use the discriminant, which is the part underneath the quadratic, underneath the square root in the quadratic formula, b squared minus 4ac. If that comes out to be a perfect square, must be a perfect square, then it will factor, must be a PS, perfect square. So what is b squared? 9 minus 4ac. Negative times negative is positive, so I have 9 plus 36 times 2 is 72. What's 9 plus 72 is 81. Is 81 a perfect square? Yes, it is. So it guarantees me that will factor. If that did not come out to be a perfect square, it does not factor, and I'm done as far as factoring. I would only have a GCF to factor out. That's the value of doing a quick check right there. Also, the other value is if you know it's a perfect square, it's going to factor, and say you keep coming up and you try to come up with the answer, you can't come up with it. Well, then you might end up thinking there is no perfect square. I mean, there is no factor in it. Well, yes, there is. If you did your b squared minus 4ac right, you might be struggling to come up with it, but it actually does factor if that's a perfect square. And don't forget that would include 0 as a perfect square as well. It can come out to be 0. So now I go ahead and use the Carlson method. Okay. I know the first term has to equal 9. That can be 1 and 9 or 3 and 3. Okay. I'll wait to do that in just a second. I come up with AB first. A times B is negative 18. Sorry, A times C that was is negative 18. And B is 3. So that is 6 minus 3 is 3, and 6 times negative 3 is negative 18. So there's my two numbers I need to get, 6 and negative 3. So does 9 times something give me 6 or negative 3? No, it doesn't. So it wipes that one out. So it must be 3 and 3. 3x and 3x. Doesn't both those multiply to 6 and a negative 3? Yes, it does. Outsides together and insides together. 3, since they're the same number, 3, it doesn't matter which one I do first. 3 goes into 6. 3 times 2 is 6, and 3 times negative 1 is negative 3. The key is that these two combos multiply to these two right here. Okay, and then I'm done. Because remember, this is not an equation, so I'm not setting it equal to 0 and setting each factor equal to 0. Notice this is a trinomial. If it was set equal to 0, I would have 3 answers. And notice each factor, 4x is a factor, so that would be 0. This one would give me 1/3, and this one would give me negative 2/3. There would be my 3 answers. Remember, the degree is called the degree of the polynomial. It tells you how many answers there are. All right, so now let's go ahead and do these ones right here. Okay. In fact, isn't that 5? Isn't the one I just did? No, it's a 12. It's real close to it. Okay. All right, so here we have a binomial. So I'm looking for a difference of perfect squares. Is that a perfect square? Yes. Is that a perfect square? Yes. So take the square root of each. 5y squared. 5y squared. One's a plus, one's a minus. The square root of 9 is 3. Y to the 6th. 3y to the 6th is half of that number every time. Half of the exponent. It's got to be even, remember. All right, so done. All right, number 2. If I want to check if it's a perfect, if it factored, b squared is 25 minus 4ac. I get 25 minus 24 is 1. 1 is a perfect square, so that does factor, guaranteed. So, equations, I'm going to have to set each one. There is no GCF to factor out or divide by. Okay, so I'm going right to what AB, I don't know why I keep saying AB, AC multiplies to 6, and B is negative 5. So that's going to be negative 2 and negative 3. Multiply to positive 6 and add to negative 5. Well, remember, the first term must be 6x squared. It's either 1 and 6 or 2 and 3. 6 doesn't work because 6 doesn't go into either one, so it must be 2x and 3x. Draw my two smiley faces, outsides and insides. 2 times what is negative 2? Negative 1. 3 times what is negative 3? Negative 1. And there I have it factored. Now I just set each factor equal to 0 and solve. You should be able to do those steps in your head. Just saving time. You should be able to easily do those, solve for the x pre-algebra. Okay. Number 3, factor out the GCF. There was no GCF in 2. There is one here. Factor out the 4. I'm left with 1x squared minus 2x plus 1. Okay. And this nicely factors into x minus 1 times x minus 1, which can also be written as x minus 1 quantity squared. In Algebra 2 on the DCAS, they'll say pick all that apply, means that all that are equal to it. So if we had this problem, you'd pick both of those answers. There'd be one written out like this and one as the bottom one. Now, if it asks which one is the easiest to help to graph, they're usually looking for this factored form right here to get your x-intercepts. Okay. We'll talk about more of that then. Okay, number 4. I want my leading coefficient to be positive. There is no GCF, so I'm going to divide each one by -1. Okay, to change it. So my leading coefficient is positive. So 2x squared minus 3x plus 1 equals 0. No GCF to take out, so I just go right to a times c, which is 2, and adds to b, which is -3. So that's -2 and -1, right? Multiplies to +2 and adds -3. Now here's real easy because there's only one thing that multiplies to 2x squared. That's 2x and x. So if it factors, remember my 2 outsides and my 2 insides for my smiley face. 2 times what is -2? -1. 1 times what is -1? -1. And now just set each factor equal to 0 and solve. X equals 1/2. Again, you should be able to solve that real quick in your head. And x equals 1. Okay. Last one. Again, I'm not going to have to solve it like I did in the last step of setting each factor equal to 0 because there's no equal sign. I just factor it only. So is there a GCF to take out? Yes, there is. 4x. What am I left with? 8x squared plus 2x minus 1. No equal sign. Okay. I can check to see if it factors by doing b squared minus 4ac, and that must be a perfect square. So I'd have 4 minus 4ac, 4ac. So I get 4 plus 32 equals 36. Is that a perfect square? Yes, it is. So that means this does factor. Saves myself time, so I'm making sure I'm not wasting my time. I know it will factor because it's a perfect square. Now, again, a times c is -8 and b is 2. So that's going to be 4 minus 2. 4 minus 2 is 2, and 4 times -2 is -8. There's my 2. Now, don't forget, this first term times the first term must multiply to 8x squared. Well, I have 2 combinations, either 1 and 8 or 4 and 2. Start with the height. It's 8 multiplied to 4 -2. No, it doesn't. So it must be 4x and 2x. It doesn't matter where I put the 4x and 2x because the key is my 2 outsides are linked together and my 2 insides are linked together, no matter what. And they must come to these 2 answers right here. So 4 times what is 4? 1. 2 times what is -2? -1. And I am done. Carlson method. Fastest way right there. Okay, and there you go, 24 minutes. So you'll get some warm-ups like this, and so you have examples if you ever need to look back at them to write down.